Welcome. You can make a note. From today, we will start solving problems continuously. And see, this is question 1. Earlier questions all are somewhere master questions where I have given more and more explanation. You have to first go through everything. Suddenly if you come here, you will have difficulty. And again, as I told, those who study systematically, they can easily follow my classes. Okay, now question 1. Locate centroid for given lamina, all dimensions in millimeter. I will do one thing now onwards. If the question is very simple, there is nothing is there, I will write in the beginning. But if there some technical concepts are there, important concepts are there, I will write in front of you. Or if say some calculation, see last class, everything I explained side by side for you. One of the calculation I did in front of you only. So this is very simple one. So therefore, you make systematic pattern, make a systematic notes of all this and preserve it. Start. All dimensions in millimeter. See, 100, 10, 125, 8. Class. This is actually called angle section. See, in structural engineering, it is called angle section. Some people call L section. See, angle section means it can be like this. It can be sometime like this. It can be like this. It can be like this also. Okay, now, there are equal angle, unequal angle. Equal angle means the two sides are equal, thickness are equal. Unequal angle means sides are different. Now, see, this question already solved this type of orientation. Long back, I solved it. So you go through it once again. This is solved already. Little earlier, as soon as I explained concept of CG, I told concept-based question. You once again go back and solve. Okay, now, this is our class question. So, okay, start. Let us divide the given lamina into two parts. See, this way. You can either divide like this. See, this lamina. See, you can either divide like this, or you can also divide like this. But usually I prefer to divide horizontally, this way. But here don't write anything. Here nothing to be done. Okay, I will do this way. Now, component 1, component 2. See here, 100, thickness 10, 10. Component 1. This is 125. See, we divided here. This full is 125. From 125, subtract 10, you will get 115. Remember, it is calculated answer. Okay, then thickness is 8. This I will remove. Okay. Now, immediately, one neat sketch required. See, as neat as possible. 100 by 10, 115, 125. I told boundary dimensions are required always. Then consider reference axis OX, OY as shown. We will take, see, I told already, bottom left extreme corner. See, origin O, most popular, bottom extreme left corner. Okay. Then this is X, this is Y. This all explained already. Maybe after some time I will take one extra class where these concept I will revise and then I will tell in future I won't explain. Okay. X, Y. Then X bar. X bar which side? They are also equally important. When you write X bar, direction required. How you are getting X bar? See, since you are taking X this way, your X bar is like this. Y bar is this way. X bar from where? That X bar is from OY. From OY. Y bar is from OX. Leave it, OX. Okay, start. A1x1, A2x2 by area, total area. The same formula, A1x, A1y1, A2y2 by total area. Now do one thing. Such a simple one, table all not required. Directly calculate. See. Therefore, X bar to right side from OY equal to, see here. This, if you want, you can write A1, A2, what is the meaning of that one, not required. See. G1 here, center. From here to here, X1, 100 by 2. So, area, 100 into 10 is the A1. See, A1, X1 from here to centroid. That is 100 by 2. Table not required. Plus, second area, A2, 8 into 115. I wrote here. into its centroid from here. See, this full is 100. From 100, you come back, subtract half of 8. I wrote here, see, 100 minus 8 by 2 divided by this area plus this area, total area. I think I don't have to explain area. You get x bar 72.042 millimeter. Same way, y bar from bottom. A1, 100 into 10 is area. Its centroid is here. From bottom edge, y1, see, this is y1. From 1 to either, see, 115 plus half of 10. Or you can do one thing, you can make a note. Or 125 minus half of 10. You can make a note here. Whatever you do, same answer. Plus A2. 8 into 115 is the area, into its centroid is here. From here to here is 115 by 2 divided by A1 plus A2. Y bar will come in millimeter. Then immediately, see, from here, see, from there, see, once you write this formula, then I'll tell you what to do. See, once you find the formula here, from there you have to come here. Where? Here. See, here you have to come. Then lastly, centroid G for given lamina will be as shown below. See here, from here, x bar, we got 72.042. So center is 100. It will cross 100. It will go this side. And from here, y bar, we got 99.052, means it will go above the midpoint of this rectangle. See, quite here, 99.052. This is centroid G. Later, this is called XXYY axis, very later. Now, this is 72.042. Suppose somebody wants this distance. From 100, subtract it, get the distance. Rounded means calculated. Or from total 125, subtract this distance, you get this distance. Now, those who want can do one thing. Take origin here, and take x left side, y down. Your x bar will come 27.958, y bar will come 25.948. Okay, this question over. Now, question 2. Locate centroid for given lamina. Actually, I prepared a question there to save the time because I thought, what is there in this question? See, I already long back, remember, one angle of this type is solved in the class. Just now, we solved an angle of this type. Now I will solve an angle of this type. Actually, not required. Okay. 90 by 60. Okay, here. This way, 90 by 60. Thickness are 8. Both are 8. Both thickness equal. It's up in, yes. No, I will do that little later because one more question I prepared there. This way. I will prepare for solve this question. Then I will go because equal thickness later. This is 150. This is 16. 16. How much I want there? 12. Actually, I am seeing there because I made a note. 200. Okay. This way. See. This is 200. This is 150. This is to save the time. There is nothing here. No one will tell he is looking at his own solution. Anybody, half knowledge also they can solve. 16. All dimensions in millimeter. This angle. Right here. This all over. Now, let us divide the angle into two parts as shown. We divide. How? We will divide horizontally. See. One rectangle here. One more rectangle here. This is thicker. Okay, out of scale. I will take this as part 1. Your choice. This is part 1. This is part 2. Okay, then this dimension is 200. This thickness is how much? 12. This distance is from 150 subtract 12, you will get 138. Show the calculation. This thickness is 16. Okay. Now, prepare a neat sketch. $200, 12, okay, 12 and 200, and this is 138, but little thicker, okay. little thicker. Somewhere here. This thickness is 12. This depth is 138. This thickness is 16. This width is 200. 200. Overall depth, if you want, from here to here, somewhere mark always, overall depth is original one, 150. 150. Okay, now start. This is your part 1. Anyone you can take part 1, anyone you can take part 2. Okay. Centroid of part 1, centroid of part 2. G1, G2. Okay, start. Now, reference axis, once again, from there you come here. Once again, same thing, most popular. I will take origin here. How? Bottom left corner. So now this will be your x, and this way will be your y, the same as last time. So this expression remains same, but the calculation will change. Okay, I will change the calculation. See, start. No table required. X bar equal to, see correctly now, x bar equal to A1, 200 by 12. 200 by 12 is A1 into x1. It's centroid from here. This is 200, so half of 200. Don't write 100. In the class I will object if student will 100. Tell me what is on the board. Okay, then this area, 16 into 138 into its centroid from this line. 16 by 2, very simple, see, 16 by 2 divided by total area is 200 into 12 plus 16 into 138. This answer will come, I already calculated there, 55.917, already calculated, so save the time, 55.917 millimeter. Okay, then y bar equal to A1, 200 by 12. A1, now remember, your y is measured from bottom here, see, into 138 plus half of 12, into 138 plus 12 by 2, plus A2, 16 into 138, 138, second area, into, from here to here is 138 by 2. See, very simple. That's why I am not preparing table here. Divide by, actually you should write yourself, area 200 by 12 plus 16 by 138. This will come, how much I got there? Y bar from here, 108.0625. 108.0625 millimeter I got. Okay, now do one thing. Present the answer. How to present the answer? Therefore, centroid G for the given lamina will be as shown in figure. See, presentation. Original diagram you have to write always. But when you go to moment of inertia calculation, you have to enter it here only. At that time, our purpose is moment of inertia. Now our purpose is only centroid. Okay. 200, see, approximate scale. This is 200. Thickness is, how much thickness? 12. This is 150. Little bigger thickness. Okay. Somewhat scale. Okay. Little more. I think I can come up to here, I think. No problem. 1 minute. Usual doubt whether running out of space or not. No, plenty of space is there. Now, don't bother about someone will comment that line is not straight line. See, those all for people who want to comment. Okay, see. Now, see, this is your origin. This way is x. This way is y. We got from OY x bar 55.917. See here, this is 200. Midpoint is 100. So little this side. So this is your x bar equal to 55.917. If you want, you can do one thing. From that edge, if you want, you can calculate this distance From 200, subtract it, it will come 144.083. Suppose you find x bar from that side, you will get 144.083. And y bar, from bottom, you have to go by how much? 108.0625. This is 138. Midpoint is here. So it will be slightly above. See here. This is where to mark. Anywhere you can mark. See here. From here, this is your y bar. Y bar equal to 108.0625. All you write here, all dimensions are in millimeter. Okay. And then if you want, you can find this distance from there. From there, if you want top edge, this will be from total 150, subtract it, it will be 41.9375. Okay, round off means calculated. Question is over. Now, question number 3. Locate centroid for the given lamina. I will give once again unequal. This time I will change the shape. The shape is like this. 60 by 90. Actually, it's a very popular. It is an angle section used by IS code in steel structures. If you go to steel structure, where steel tables, if you see, or IS handbook, you can see ISA, Indian Standard Angle, 90 by 60 by 8. So, this is 90, this is 60, thickness is 8, both are 8. Actually, both 8 is of no use for us. Okay, start. Divide into parts. See, right here. Let us divide into parts. Statement all you have to write once again. This way, 90. This way it will come. Horizontally I will divide. Other is smaller this way. Okay. Now, this is 90. This thickness is 8. This also 8. This distance will be from 60, subtract this, not that 8. Subtract this 8, 52. Make a note how you got. From 60, subtract this 8, not that 8. Okay, over. Now, neat sketch once again. It's out of scale. Okay. Dimensions here, once again. 90, 8. See, you can see I have 52. This is 8. If you want, write overall dimension also. Somewhere here, overall dimension. Overall is 90. Oh, sorry, it's already here only. Oh, no, not that overall. This overall. That's already there. Why write once again? This overall is 60. Start. Corner, origin. Once again popular. I will change later. We will take this origin. Oh, same, no change. Usually people want like this. This is your x. This is your y. Next time some questions I will change it. Okay. Same statement you write. Same statement you write. Everything same statements you write. Calculation will change. Start. X bar. Figure number, I forgot right. Okay, this side, anyone you can take one. I will take this time for a change. This is 1, this is 2. So, this is your figure 1, this is your part component 2. Now, centroid G1 here, centroid G2 here. Start. Area of figure 1 or component 1, 90 by 8. 90 by 8 into its centroid from here. This is 90, from here to here is half of 90. 90 by 2 plus 2, second one. 8 by 52 is the area. Multiplied by its centroid from here is, see, this is 90, from 90, what you have to do? Subtract half of 8. See, from here to here is 90 minus 8 by 2. That much common sense. Divide by total area 90 by 8 plus 8 by 52. Your answer will come for that question from here 60.014 60.014 millimeter. And y bar will come from here. See, first one 90 by 8 is the area. 90 by 8 is the area into its centroid is here. This distance is 8 by 2 midpoint plus second area 8 into 52. Second area into its centroid from bottom edge is 8, then half of 52. 8 plus another 52 by 2. This all explained for you earlier. Divide by same. Next time I will not waste time here. Plus 8 by 52. By chance, if any calculation mistake is there, don't make an issue. You check the answer. It will come. That question is 14.986. 14.986 millimeter. Okay. Now, right, last answer. Therefore, centroid G will be as shown in figure. See. Put the original sketch. How is the original sketch? 60 by 90. Okay. Red color is coming. 1 minute. Okay. This is a color problem. Sometimes students I will tell, see, you got subject confusion, I got color confusion. 60 here. 60, 90, thickness is both are 8. Dimensions not required. Okay. Our origin is here. Our origin is here. Oh, this is your x. This way x. This way y. Now, x, see, now you should not divide. See, now dividing is not there, right? The original diagram. X this way, x bar is 60.014. This is 90. Midpoint is 45. So it will go that side. See, red color. From here you have to go by how much? 60.014 means it will come somewhere here. Okay. This is your x bar. See, this is your x bar equal to 60.014 millimeter. All dimensions are in millimeter right there. And from, if you want, from this side, it will be total 90, subtract 60.014, it will come 29.986. Calculate it. Okay. Actually, these values are there in the steel tables. And same way, this way, from this axis, y bar, this way y bar, we got 14.986. See, this is actually 8. So little more. From here, this is your y bar equal, I will write there. Okay, no problem, space is not there. Okay. I'll bring the x this side. X, okay. This is your y bar equal to 14 point, it is answer 986. 986. Then from here if you want, it will be total 60, subtract it, it will come 41.937, 41. No, some other question. I am seeing some other question. This is correct, x bar 60.014, 29, y bar 14.986, 45.014 over calculated value. This I forgot, last time forgot, now you mark G. I think last question I wrote G but forgot to mark it. You mark it, centroid G. Okay, now all these questions are over. Just a minute. Today single stretch recording. I am doing only 4 questions today. That is angles. Okay, now one important aspect. One concept question. Concept is not a big one. See. Question 4. I removed the question. Okay. I should not have removed it. Okay, next question 4. Something interesting. Okay, not big interesting. Question 4. Locate centroid. Locate centroid for not lamina given angle section. angle section. What I will do is, now see, long back I took one angle like this, over. Today's class, one question I took angle like this. One more question I took angle like this, and this over. Almost everything is over, I think. Sufficient. Now see, once again go back to old one. See, this way angle, but something special. See, angle section given. Now see, this way given, and they told angle section, see, in the bracket 150 mm by 150 mm by 15 mm in the question given. That means you write here, that means this is called equal angle. You write here, equal angle, this is 150, this also 150, and thickness is 15, see, 15. It is the usual way in Indian standard of specification of angle, ISA, Indian standard angle, they will tell 150 by 150, the two sides, and the thickness. See, orientation can be anything. I will put this way orientation. Okay. Now, why I am telling? Because this is a very popular angle I used in steel structures, especially plate gird. Nowadays, bolted plate girders are not used. Olden days, bolted plate girders or riveted plate girders are widely used. You require huge flange angle. So, long back, when I took steel structures class, design and drawing of steel, I usually select ISA 150 by 150 by 15. I know that as per the steel table, its area equal to 42.78 centimeter square. I know it, 78 centimeter square. And its X bar and Y bar are equal to 4.26 centimeter. But remember that values are given considering the angle like this. See, some curvature is there here, and here some, see, turning. This way is the angle. So they considered the curvature, and here see, root, some the radius is there for this one. See, you can see some curvature. It is not straight. So therefore, if you do by our engineering mechanics, exact same value will not come, because these and moment of inertia is 896.8 centimeter power 4. I know it. I know that answer, 896.8, because I used it more than 1,100 times. Okay, now, just a note only I told. But see, but what they done is, they accounted for the curvature, etc. Everything is accounted. But engineering mechanics, we are not knowing. Therefore, we will take rectangle. So, slight change in the value will come. Okay, leave it now. Start. Let us divide the given lamina into two parts. How to divide? Left to your choice. Okay, you divide like this. One part here. See, this way you will divide. Therefore, this will be 150. Now, even though this is 150, see, this is 150 no doubt, but since you divide here, this will become from 150 subtract 15, 135. Thickness is 15, thickness is 15. Okay. Consider reference axis. See, now I'll tell you something interesting now. See, start. Put the sketch. Okay. Dimensions. This is 135. This is 15. This also is 15. This is 150. I will take anyone. This is part 1. This is part 1. This is part 2. Okay. Part 1 and part 2. Now, centroid is here. Centroid is here. Start. Let origin. We will take again this origin, O. So therefore, this will be your X. This all I explained. I don't know how many times I explained it. Somebody may tell, what is X? He is not explaining. Then don't attend my class. I will tell X and Y. Let X bar and Y bar, etc. statement. As usual, write all the statement. Then write the formula for X bar, Y bar. Start calculating. But one thing now, when you start calculating, see here, your x bar will be, see, after all this statement and after the statement you come here and write, therefore x bar from where? X bar from your OY line, how x bar to right side equal to A1. How much A1? This area, 15 into 135. 15 into 135 into x1 from here to here is 15 by 2 plus 150 into 15, second area, into its centroid from this line is 150 by 2. So simple. Divided by area is 15 into 135 first area plus 150 into 15. X bar will come. I will tell you first area. The total area is 15 into 135. Sorry, calculate not on. 15 into 135 plus 150 into 15. 4275. Don't worry. It is 4275 mm square. But in steel table, it is 4278 because this 4275 is centimeter square. I forgot. Centimeter square. 4278 is the answer in steel table, but because of curvature effect is there. But the plain answer is 4275. So answer is 15 into 135 plus 150 into 15. Now x bar 15 into 135 into 7.5 plus 150 into 15 into 75 divided by 4275 is 43.43. How 43? One nimisha. 42, 4.26 I remember. I think I'm wrong. 15 into 135 plus 150 also into 15. Area is 4275, correct? 4275. Then 15 into 135 into 15 by 2 plus 15 into 130 plus 150 into 15 into 75 divided by 4275. 43 coming. Yes, 40, it's okay, 43. It is 43.026. 43.026 millimeter. Actually, IS handbook, they have printed 4.2, area is 4278, 4.26 or 42.6 is the answer. It is 43. See, 0.4 difference because of the curvature, little more area, centroid slightly shifts there. If you are doing steel structures, you should take as per the IS code. If you do engineering mechanics, take like this. Okay, now x bar over. There is no need of calculating y bar because, see, you make a note here. 150 by 150, 15, 15. For equal angle, if the both sides are equal and thickness is equal, how much is x bar from here will be equal to y bar from here. See, you turn it. Therefore, right here, that directly y bar from where? Y bar from OX. Y bar from OX equal to, you are equal to, I will write here, that y bar x is equal to x bar from OY. From OY equal to 43.026 millimeter. Okay. Or if you are that much eager, what to do? Okay, right here. Or start. Y bar equal to. Any color will do. Y bar equal to. A1, 15 into 135. Into its centroid is here. From here, 15 plus 135 by 2. 15 plus 135 by 2. A1, Y1 plus A2. 150 into 15. Into centroid is here. 15 by 2. Divided by the total area 15 into 135 plus 150 into 15. Surely answer will come same. How much? not required, equal to, I'll write here now, equal to 43.026, not 26 millimeter over. Okay, now last step of presentation. See, I'll do one thing now. This time space problem is not there. I can rub whatever I want, I can rub now. Nothing required because see, all dimensions millimeter. Okay, I write here. Therefore, centroid G for the given angle will be as shown below. 150, 150. Thickness 15, thickness 15. Okay. Both are equal thickness. Okay, now see, from here, x bar, we got 43. This is 150, half is 75. That is somewhere here. See, when you do x bar, when you mark the x distance, you should put a reference vertical line there. Okay. Once again, to understand correctly, this is the point O. This way is your x, this way is your y, and we got x bar 43.026 millimeter. Therefore, if you want this distance, you can calculate. If you want, actually arrow mark from that side. From 150, subtract 43.026, 106.974. If you want, you can calculate. Then, same way, y bar this way is, once again, same answer. See? Actually, this distance equal to this distance. Like, see, like I told quadrant, see there? This distance equal to this distance. This is your y bar from here, upper side. This is y bar equal to, once again, 43.026. If you want, from there to here, from 150 subtract 106.974. Okay, now angle sections are over. 4 questions I solved. 1 question long back I solved. If you remember, once I took origin here, once I took origin there, dividing also I told once divide this way, once divide that way. That is a multiple concept there. Now go through, very simple class today. Today's class is actually, I can as well need not solve in the class. But I decided in the class, I will solve maximum question. Exercises, plenty of questions, class I can't give. It will take a lot of time. So that advantage is only for those who go for the notes. In the notes, I will give plenty of questions with sometimes little more information, sometimes brief solution, sometimes I will tell directly do it. Like exercise, you have to follow completely. In the class, whatever I do, those who are depending on the class, you have to practice everything. Okay. Thank you. We'll meet in the next class.